Bismillahirrahmanirrahim. Assalamu alaikum. My name is Professor Dr. Rizwan Rashi. Welcome to the lecture number 9 of IT Need Assessment and Technology Evaluation course. In my previous video, I was discussing about the product lifecycle models, and we have predictive models and adaptive models. Predictive models are also called classical models or traditional method models. We also call them methodologies, whereas adaptive models are also called modern methodologies or agile methodologies. In the predictive, we have waterfall, spiral, incremental, prototype, Rad, rational unified. I covered waterfall methodology and prototype methodology in my last lecture. Today, I'm going to cover the Rad methodology. The Rad methodology is also called Rapid Application Development Methodology, and it has 4 phases: requirements and planning, modeling, construction, and cutover. The 7 phases of waterfall methodology are merged into 4 phases. For example, project identification and selection, project initiation and planning, analysis. They are covered in one phase called requirements and planning. So we are doing analysis and we are doing planning at the first phase of RAD methodology, the rapid application methodology. Then the modeling. The logical design and physical design phases are merged into one phase called modeling. So 5 phases are covered in 2 phases of RAD methodology. That is the reason it's called rapid application methodology. And then you have implementation or construction and the cutover, including the deployment and the maintenance activities, training, security. RAD methodology has only 2 phases, which are iterative. That means from modeling and construction, we can go back, because at the modeling level or at the implementation level, construction level, we are using prototype. And because of the prototype, the feedback, we can go back and we can change the design and we can have the implementation or construction, the coding. Construction is called coding testing. So we can code, we can test, and then we can go back to the previous phase, that is the modeling. The rest of the phases, they are not going back like the waterfall methodology, that each phase is going back to the previous phase. So a lot of verification is there. But RAD methodology is using prototype methodology at the second phase and the third phase, which are iterative. RAD methodology has several advantages. Rapid application methodology is introduced to develop small and medium projects. We can cover more complete user requirements because we are using prototype heavily at the modeling level and at the construction level. But because of that, there are some drawbacks, because RAD methodology is not suitable for large projects. It's not suitable for safety critical projects where human life risks are involved, and we use waterfall methodology at that level or for such projects. There are another problems with the RAD methodology, that all the limitations of prototype model is introduced into the RAD methodology, that we are doing at the fast rate. We are developing at a fast rate. Because of that, there is a chance of low quality in the software, or poor quality software will be the end product. Then spiral methodology is introduced by Barry Boone for large projects, because RAD methodology addressed the problem of software industry to develop small and medium projects up to 6-month project or up to 1-year project. But there was no methodology available to apply for large projects, and spiral model was introduced. Spiral model is unique in several ways. The first thing in the spiral model, We have incremental development, first time introduced in the history of software engineering. Before that, using waterfall or Rad methodology, we deliver the software as full package, as a whole package. But after the spiral model, which is also called incremental methodology, we start delivering the software in increments. Second feature of spiral model, that before spiral model, software development is called software development or software construction, but nobody called it software engineering because Barry Boehm introduced the word of engineering in the spiral model. We have customer communication, planning, risk analysis, engineering, testing, and customer evaluation. So customer communication is the first phase, planning is the second phase, risk analysis is the third phase, engineering is the fourth phase, testing is the fifth, and customer evaluation, customer feedback is the sixth. Third feature of spiral model, that we have risk analysis. So risk management is introduced in the software engineering discipline. That is the three main contributions of Barry Boehm, that he introduced the spiral methodology to deliver software in increments. We start using a word for software engineering. So software engineering field was established. Before that, we don't have software engineering course or software engineering field discipline. And risk management is introduced to cater the possible risk regarding the project. That is the third main contribution. Now comes to the phases. We communicate with the customer, we do planning to deliver, to have contract with the customer, the agreement, and then we do risk management, we do analysis, we do risk management, and we have engineering. In the engineering, we merge design and development phases first time in the history of software engineering, in the history of methodologies, because now using the spiral model, the fourth main contribution that I missed, that you can have multiple teams that can work in parallel. So for example, the designing team is working on the first release, and once they complete their design, they deliver to the development team or software engineers or programmers. Meanwhile, the designing team is working on the second release to design the second release. And you can have multiple teams that can work together and on the same project on the different parts of the project. For example, different modules of the project. You can have one team in Pakistan, one team in America or India or Dubai or Sri Lanka or Bangladesh. So for example, in case of multiple teams, you can work on multiple projects, like the case of many companies now. The American Silicon Valley is almost, most of the companies are shifted to Bangalore. So half teams are in America, half teams in India. And in Pakistan, there are so many companies, they have offices in America and the half teams are in Pakistan, like IT24 or Descom or Systems or Techlogics or NextBridge. So there are so many companies that are working in this style, that half teams are in America, half teams are in distributed environment in Pakistan, India, Bangladesh, Sri Lanka. So these are the few main contributions of spiral model. And because of the Barry Boehm, we have the incremental development, we have the software engineering field, we have the risk management, we have a concept of distributed teams. So multiple teams can work on the same project. We can hire more than one teams. Spiral model has some advantages and some disadvantages. For example, spiral model is introduced for structured development. There is no concept of object-oriented in the spiral model. Secondly, It's not suitable for small projects. It's not suitable for safety critical projects because there are so many phases, 6 phases, and all these phases need time, cost, effort, resources to develop a project. So because of that, it is not applicable for small projects. It is not suitable for safety critical projects because we are continuously changing the architecture and design. And that is the fundamental requirement of safety critical projects, that you have to freeze the requirements. And here we are continuously gathering the requirements as per the demands, as per the requirements of the customer. So these are the some problems with the spiral model. Because of that, object-oriented methodologies were introduced and rational unified process was introduced. That is also predictive model or traditional model or classical model. Rational unified process is first time implemented for an IBM project, and then software industry started using that. Rational unified process has phases like the other methodologies, but it has workflow as well. It has activities as well. Inception is the first phase. Elaboration is the second phase. Construction is the third phase. Transition is the fourth phase. And then you have communication, planning, modeling, construction, deployment, and the release is there. Customer communication and planning, they are connected with inception. The planning and modeling. Modeling means analysis and design in rational unified process, unlike the Rad methodology where modeling means logical design and physical design. So analysis and design are merged here. So after customer communication, you do planning, and then they are connected with the inception phase. The modeling, analysis, and design activities are connected with also with the inception and also with the elaboration. So you have feedback cycle. You can have iterative cycle. It has small sub-cycles. For example, first sub-cycle is between customer communication and planning. Second sub-cycle between planning and modeling. That's connected with elaboration. Construction is connected with construction. Transition is connected with construction and deployment. So the third sub-cycle is between construction and deployment. So I'm talking about the second sub-cycle. So for our first sub-cycle, when you do plan, you feel there are some thing required from the customer to communicate, to make it clear. So you do planning, you do communication again to improve your plan. So there is a chance of feedback. Instead, you complete the cycle and you deal like the spiral model. If you need something, you want to make some changes, you have to wait for the second cycle. But in rational unified process, you have a chance to go back and rectify your mistakes. Then, when you have modeling, analysis, and design, you do analysis, you collect requirements from the customer in detail. So detailed requirements are gathered. You feel your plan, your cost estimation, schedule estimations are not as per the detailed requirements. You miss some requirements during the plan that you found during the analysis. So you can go back and you can change your plan. That is the second sub-cycle. You do construction, and then at the transition means like transit flights. Transition means you ask the customer to have alpha testing and beta testing. In the alpha testing, you call the customer at the software company site. So during the alpha testing, you find there are some bugs. So you can go back to the construction phase and the construction activity, and you can rectify your mistakes. You can fix debug. You can fix those bugs. You can change the code to make improvement. So that's the third subcycle. And then in the deployment activity, you ask the customer for beta testing. And in the beta testing, again, you find some bugs which are called defects. You can go back and you can correct in the construction activity. So that's the advantage of third subcycle. The main advantage of rational unified process, it is used for object-oriented development. The first time UML modeling was introduced as a part of methodology. So we have use case diagram, class diagram, sequence diagram, and so on. Deployment diagram, package diagram, state transition diagram, activity diagram. And then you have 3 verification cycles. Because of that, the end product will be high quality software. And it is the most widely used methodology before the agile methodology and before the 9/11. So there is paradigm shift because of the 9/11 incident, the world before 9/11 and world after 9/11, like world before COVID and world after COVID-19. Rational unified methodology is incremental, like the spiral methodology. So you can deliver the software in releases, first release, second release, third release. So all the advantages of incremental methodologies are inherited into rational unified process. There are some limitations, like nothing is perfect in this world except Allah. So you have, it's not suitable for small projects because it's time consuming, cost consuming, effort consuming, resource consuming, because a lot of verification is there like waterfall. But it's the best suitable for medium to large projects. Another problem with the rational unified process is that there is no reference within the methodology how to reuse the classes, how to reuse the code. It's up to the expertise of project manager or the system analyst how to reuse the code in the future projects. That's enough for today. Thank you very much. Jazakallah khair. May Allah bless you. Assalamu alaikum.